Okay, this is 5.5C, and we are in example number 3. And these are the ones I like. I like verifying. For some reason, that just seems something that I enjoy doing more than anything else with these particular ones. So they give me the cotangent of x times the sine of 2x, and they're saying that equals 1 plus cosine of 2x. So they're saying prove it. Prove that that's true. So we're going to start on the left side. That looks like the one that's a little more complicated. And if you remember from section 5.1, there was a table there about different ways to do this. And if we can get everything to be sine and cosine, then that would be nice. So let's get started with that. Let's ignore the right side. We're going to ignore that right now. I do know that cotangent is cosine over sine, and that's the times the sine of 2x. Okay, so I've got that. And I also know that the sine of 2x, cosine over sine, I know that the sine of 2x is the same as 2 sine of x cosine of x. Alright, I don't like those 2's in front there, so that's why I changed it to this one. Okay, so that being the case, now I can multiply. See, when I was like this, I couldn't multiply sine of 2x times cosine, but I can multiply these now. So cosine, so I get 2 cosine x sine of x and then this is squared because this times this makes it squared over sine of x, and I can cancel. And that leaves me with 2 cosine squared of x. Now, if I look back on some of my other identities, I can find out from page number 213, I know that 2 cosine squared of a, let's see what I've got here, 2 cosine squared of x. I don't have one of those, but I do have cosine of 2a equals 2 cosine squared a minus 1. So, if this is the case, then this also, if I were to add 1 to both sides, 1 plus cosine 2a equals 2 cosine squared of a. Okay, so I just set it equal to that by adding 1 to both sides. So if that is what I found there, then this also, or this, whichever one I want, equals this here. And if we look at this, it's the same as this. 1 plus cosine of 2 times the angle, 1 plus cosine of 2 times the angle. So, being able to take the original equation here, identity, and being able to flip it and make it look like this is pretty important to be able to recognize being able to do that. So, that was one of the reasons why I wanted to show you that example. Alright, example 4. We have cosine squared 7x minus sine squared 7x. And we're supposed to simplify that. We're supposed to make it easier. Alright, so let's go ahead and do that. Alright, so I brought on the double angle identity table to help us look at this. And let's pretend that 7x is my angle that I'm looking for. Okay? So that's what I'm looking for. Or I guess I should say that equals angle A, because we're going to use this formula right there. We could use any of the 3 that we want, but we'll use that one, and it uses A. So cosine squared of A, which in this case it's going to be 7x, that's our A, minus sine squared 7x, that's our A, equals cosine 2 times our angle, which we said was 7x. Okay, cosine of 2 times 7x is 14x. So, there we go, simplified. We just took this right here, used this formula, and it equals that. Alright, so if we look at sine of 15, cosine of 15. Okay, so this is part B of example 4, and I'm not going to do it like they do it in the book. I'm going to suggest another way of doing it, and I'm not going to do all the work, but rather than fight with using their identities there and figure out what they're doing, because I just don't know how a normal person would just come up with, oh, okay, well, I'll do it this way. When we can take the sine of 15 and know that that's the sine of 45 minus 30, and then that equals, remember back in, earlier lessons, page 205, sine of a sum or difference. And then we multiply that with, so we take that formula, which ends up being, if you remember that, sine of 45 cosine of 30 minus cosine of 45 times the sine of 30. Take that and multiply it by, instead of the cosine of 15, we'll write that as the cosine of 45 minus 30, and then use the formula on page number, where is it? It is back on page 198. So then that would help you be able to figure this out. So you would take this and figure it out, and then do the same thing with that one when you get it in this form, and multiply the two together, and you should be able to get 1/4 for an answer. Alright, so continuing along, let's skip some stuff and jump to example 7, using the product to sum identities right above that. Examples 5 and 6, you don't have to worry about those. So we're trying to write the cosine of 2 theta, sine of theta, as the sum or difference of two functions. So that means rather than have these two functions multiplied by each other, we're going to write those as the sum or difference. In this case, we're going to do the difference of two functions. So we're going to have a minus sign somewhere in here. Alright, so what we're going to do is we're going to look at cosine of 2 theta times the sine of theta. So we're going to look at the table above. Let me get that on here. And if we look at this table here, notice we have a cosine of an angle and the sine of an angle. So that looks like this one right here. It's the only one that we're going to use. So the cosine of 2 theta sine of theta equals 1/2 sine of 2 theta plus theta minus the sine of 2 theta minus theta. And there's our problem there. Alright, so let's keep going. 1/2. We're just going to do some simple math here. 3 theta minus the sine of 1 theta. Okay. Now we're going to distribute this 1/2. 1/2 sine of 3 theta minus 1/2 sine of theta. And we are done. That's all you can do with that. Okay, it's the sum or difference, there's a minus sign, of two functions. And this last one is sum to product identities. There's one, and if you look on the previous page, there's another list of sum to look at. So let me get a picture of that. So what these sum to product identities do is it changes something from the sum of two trig functions to a multiplication. We're multiplying over here in the same way over here. So they give us an example, and they want the sine of 2 theta minus the sine of 4 theta, and they want you to express that as a product of two functions. So let's see, which one am I going to use? Looks like this is the one that we're going to have to use for that, because it's got the sine of A minus sine of B, which this has. So let's go ahead and write that information there. Equals 2 cosine angle A is 2 theta plus 4 theta over 2 times the sine of 2 theta minus 4 theta over 2. Alright, so that gives me 2 cosine 2 theta plus 4 theta is 6 theta over 2, which is going to be 3 theta eventually. Sine of 2 theta minus 4 theta is negative 2 theta over 2. Okay, so this will cancel, and that will change to a 3. So we have 2 cosine 3 theta sine negative theta. Let's put that in here. Alright, so we have that sine of negative theta. We can take that negative and just pull it out and put it over here, and it'll go away there. So we end up with negative 2 cosine of 3 theta sine of theta. And the reason we could take that negative and move it out is because in section 5.1, if we have a sine with a negative angle in it, that's the same as negative sine of theta. So we can take this negative in here and pull it out and put it in front, just like we did here. Okay, so that's it for lesson 5.5. The exercises are just exactly like the ones that I just did, so I'm not going to go over any problems there, because basically it's just going to be redoing these. So if you have any questions, just let me know. Make very good use of your book, your solution manual there.